Let's practice calculating the area of rectangles and triangles given their ordered pairs together. For each of these practice problems, let's go ahead and make a rough sketch of each of these polygons on a coordinate plane, and then we're going to go ahead and determine the area of each of these shapes with their coordinates that we have. And here are 4 dots that we can use for our plotting of the points. So we'll go ahead and call this one point A, this one point B, this one point C, and point D. Alright, so just a rough sketch of the XY axis. Let's go ahead and plot point A, which is going to be 4 to the left and then 5 units up, maybe something like this. For point B, we're going to start at the origin, move 6 units to the right, and then we'll move 5 units up. That'll be in quadrant 1, maybe something like this. For point C, we'll start at the origin and move 6 units to the right, and then 3 units down, maybe over here. And then finally for point D, we're going to start at the origin, move to the left 4 units, and then down 3 units. So roughly over here. Okay, so these would be our 4 points. We can go ahead then and just connect these 4 different corners or 4 coordinates, and we should get a rectangle, just because we can see that they have matching x and y values going around. So to find the length of AB here, we're going to have to look at these 2 coordinates for A and B. Notice they have matching y values, so we have to take a look at their x values, and they're in different quadrants here, right? So to find the length of segment AB, what we're going to do is add the absolute value of their non-matching values. So that's the absolute value of -4 plus the absolute value of 6. The absolute value of -4 is 4 plus 6. So 4 plus 6 is going to equal 10, so that's going to be 10 units, and that's going to be the length of this segment AB. Okay, now we also want to figure out how long BC is, because to find the area we need a length and a width. So for BC, we can see here that they have matching x coordinates, so 6 and 6 match. So we have to compare their non-matching values of 5 and -3. All right, so they're in different quadrants, so if we want to find out the length of CB or BC, however you want to call it, is fine. Then we'll go ahead and add their absolute values of their non-matching numbers. So that's going to be the absolute value of 5 plus the absolute value of -3. Now 5 plus 3 is really what we're adding here, and that's going to be a total of 8 units. Okay, so that's going to be the width here, or the length, whatever you want to call it. Okay, so we now know the length and the width. We can go ahead and say that this right here, we can point to this 10 units. Let's call it the length maybe, and this 8 units, we can call that the width. And recall that if you are finding the area of a rectangle, area is length times width. So if that's true, then the length is going to be 10 units and the width is going to be 8 units. And so 10 times 8 is going to be 80, so we have 80 units squared. All right, so that right there would be the area for this rectangle. Let's check out number 2. For number 2, we're going to go ahead and need 4 more points, so let's go ahead and draw those out. So we're going to have point E, and then F, G, then H. All right, so just making a rough sketch and plotting these points. For E, we're going to move 6 units to the right and then 3 units up. We can plot point E there. Then for F, we're going to start at the origin, move 6 units to the right and then 7 units down for that -7, maybe something like here. Then for G, we're going to start at the origin, move 2 units to the right and then 7 units down, maybe somewhere like over here. That should also be in quadrant 4. And then H is going to be 2 units to the right, but then 3 units up. Okay, so looking at these, we're going to see that we have roughly a rectangle, just like in the last example as well. So if we connect these dots, then we should get a rectangle here, or a nice quadrilateral. So to find the area, we need to go ahead and find the lengths or the width. So the distance of HE, if we go ahead and look at E over here and H, notice how they have matching y values of 3. So this 2 and this 6 are really what we're looking for here. Now they're in the same quadrant, so make sure we subtract their absolute values. So if we want to find the length of segment HE, then what we're going to do is we are going to take the absolute value of 6 and we're going to take away the absolute value of 2 since they're in the same quadrant. Now the absolute value of 6 is 6, the absolute value of 2 is 2. 6 minus 2, that's going to be 4 units. So that is going to be the dimension here. Okay, next, now that we have HE, we really want EF. Okay, so EF, we can notice here, is going to be these 2 points. What do they have that are matching? Well, it looks like they have the 6 and the 6. So their non-matching values are 3 and -7. So since they're in different quadrants, let's go ahead and add their absolute values. So for segment EF, we can go ahead and add the absolute values of their non-matching numbers. So we have the absolute value of 3 plus the absolute value of -7. And so the absolute value of 3 is 3, and the absolute value of -7 is 7. 3 plus 7, that's going to be 10 units. Okay, so we can go ahead and call this one maybe the length and call this one the width. Doesn't really matter because we're just finding area here. Now, if area's formula for rectangles is length times width, then the length here would be 4 units and the width here would be 10 units. And 4 times 10 is going to be 40, and units times units would just be units squared, or square units. So this would be the area of this rectangle. Here's number 3. For number 3, notice that we actually have 3 points instead of 4, so we're not dealing with a rectangle. So we'll call this first one point A, then we have point B, and then point C. And now let's go ahead and plot these points. So for point A, we're gonna move 4 units to the left and then 5 units down, maybe somewhere like here. For point B, we're gonna go ahead and move 6 units to the right, and then we're gonna move 5 units down, so it's just gonna be to the right of point A. And then for point C, let's start the origin and move 4 units to the left, and then 7 units up, maybe somewhere like here. So these are our 3 points, and if we go ahead and connect each of these points together, we're gonna see that we do have a triangle. Now remember, to find the area of a triangle, that formula is going to be something like 1/2 base times height, or base times height divided by 2. So we really need to find out the base and the height. Now this right here would be the base, AB. So if we take a look at these 2 points for A and B, we're going to notice that they have matching y values of -5 and -5. So we look at their non-matching numbers of -4 and 6, and they're in different quadrants, so we're going to go ahead and add their absolute values. So to find the length of segment AB, which is really the base of this triangle, that's going to be the absolute value of -4 plus the absolute value of 6. Now the absolute value of -4 is 4, and the absolute value of 6 is 6. So 4 plus 6, that's going to be 10 units. Okay, so that's going to be the dimension going across here, and we're going to call that's going to be the base. Okay, and then we really need to find the height of this triangle. We don't really care about that diagonal, we just want to know how long AC is. That's the height of the triangle, so here's A, and here is C. Now notice they have matching x values, so their non-matching values are -5 and 7, and they're in different quadrants, so we're going to go ahead and add their absolute values to find how long AC is. Okay, so if we have segment AC, we want to add their absolute values. Well, A is over down at -5, and then C is up at +7. So we're going to add their absolute values. They're in different quadrants. The absolute value of -5 is 5. The absolute value of 7 is 7. 5 plus 7, that's going to equal 12. So that's 12 units. That's how tall the height is for this triangle. It's going to be 12 units tall. Okay, so we have everything we need to go ahead and find the area now. So we have 1/2 multiplied by the base. The base we found out was 10 units, and the height we found out was 12 units. So if we go ahead and do 10 times 12, that's going to be 120. So 120, and then units times units is going to be units squared. So that's going to be 120 units squared, or square units. And then half of 120 is just going to be 60. So we know the area for this triangle would be 60 square units. For number 4, we have 3 points again here, so let's go ahead and just create our 3 dots that we're going to move around to plot these points. In this case, we're going to have point D, and then point E, and then point F. Here we have a rough sketch of our coordinate plane, and then to plot point D, we're going to move 7 units to the left and then 5 units down, maybe somewhere over here. For E, we're going to start at the origin, move 4 units to the right and then 5 units down. So that seems just about right, maybe in quadrant 4. Okay, and then for F, we're going to start the origin, don't move left or right, and just move up 6 units, so maybe somewhere like here would be where F is. Okay, so this is not a right triangle, but it still is a triangle. There's DE, that's going to be the bottom of this, and then here is segment DF and segment FE. Okay, so we have a triangle. It's not a right triangle, but we can still go ahead and see if we can find out the base and the height of this thing, right? So again, for a triangle, we have area equals 1/2 base times height, or base times height divided by 2. So the base of this triangle is going to be segment DE. So let's go ahead and focus on points D and E to find out the distance between them. So they have matching y values of -5. So let's just focus on -7 and 4. They're non-matching values. They're in different quadrants. So let's go ahead and add their absolute values. Okay, so for segment DE, let's go ahead and add the absolute value of -7 and the absolute value of 4. Now the absolute value of -7 is 7, and the absolute value of 4 is 4. So 7 plus 4, that's going to be 11 units. So this is going to be the base for this triangle. Just label that with a B for the base. Okay, that's how far across it is. Now, for the height, we want to make sure we are going from the uppermost part of the triangle to the bottommost part of the triangle. So this would be the perpendicular height, or has to be going basically 90 degrees to the base. So this is the base, and so the height must be going at a right angle going up to it. So this would be the length of the height. Okay, so we got to figure out what is the height of point F here. So point F, notice how we are at 6. Okay, that's how tall it is. And where's the bottom? Well, the bottom is along where D and E are. And those both have a height of -5 and -5. So we're really trying to find out the distance of 6, which is over here, and -5. How far is 6 from -5? Well, since they are in different quadrants, we're going to go ahead and add their absolute values. Okay, so what some people might do in these scenarios is they create a new dot. You can totally create a dot here and call this G. All right, so if you want to find the length of FG, that would be the height here. Okay, but totally up to you. You don't have to create this segment if you don't want to, but we're going to see how long this FG segment is. Then it's going to be adding the absolute value of 6 and the absolute value of -5. Okay, so the absolute value of 6 is 6, and the absolute value of -5 is 5. 6 plus 5 would be 11. So we know the height of this triangle is going to be 11 units, right? That's how tall this is, and that's going to be the height. Okay, so substituting these numbers in, we have 1/2 times 11 units times 11 units, right? Now 11 times 11, that's going to be 121, so that's 121. And then units times units is square units, or units squared. And then if we do half of 121, well, half of 120 is 60, and half of 1 is just half. So it's really 60.5 square units. This would be the area of this triangle. Here's number 5. For number 5, we have 4 points here, so we're going to be talking about a rectangle. So for this first point, let's call this A, we'll call this one B, and then C, and then D. Let's now go ahead and plot these on a coordinate plane. So for point A, let's go 6 to the left and then 3 units down, maybe over here. For point B, we'll start the origin, move 6 to the left, but then we'll move 7 units up. This seems just about right. For C, let's go ahead and move 1 unit to the right and then move 7 units up. So that'll be next to B to the right of it. And then for D, let's go ahead and start the origin, move 1 to the right and then 3 units down, just about there. Okay, so if we go ahead and connect these, we can see that B and C are next to each other, A and B are on top of each other, A and D are next to each other, and C and D are above and below each other. Alrighty, so we're going to find the area of this rectangle, so that's really just going to be the length times the width here, okay? So it doesn't matter which one we call which, but maybe call BC the length here, okay? So BC would be the distance between these 2 points. Notice they have matching Y values of 7, so they have non-matching X values, so we're going to add their absolute values to find out the distance between them. So we have the segment BC, that's going to be equal to the absolute value of -6 plus the absolute value of 1. Now the absolute value of -6 is 6, and the absolute value of 1 is 1. 6 plus 1, that's going to be 7 units, so that's how far it is from B to C, okay? It doesn't matter if you call this the length or the width, I'll call this the length. Now we also have to find out how long AB is, right? Or CD, doesn't matter. And that'll be our width. So for A and B, if we go ahead and see those two values, they have matching X's. So if we look at their Y's, they have non-matching Y's in terms of being in different quadrants. So let's add their absolute values to find the distance between them. Okay, so to find the segment AB, let's go ahead and say that's going to be the absolute value of -3 plus the absolute value of 7. The absolute value of -3 is 3, the absolute value of 7 is 7. 3 plus 7, that's going to be 10, so it's going to be 10 units. So that's how long segment AB is. So this 10 units for segment AB, we can call the width, since we called BC the length. Okay, so the length here is going to be 7 units. Let's substitute that in. And then the width is going to be 10 units. We can substitute that in. Now 7 times 10 is 70, and then units times units is square units. So we can go ahead and say we understand that we know the area for this rectangle is 70 square units. All right, for number 6, looks like we have a triangle, right? So we have 3 points, so 1, 2, and 3. We'll call this first one point A, then point B, and then point C. Plotting this on a coordinate plane, point A is going to move 7 units to the left, and then 4 units down, maybe somewhere like over here. For point B, let's go 1 to the left, but then go 6 units up, maybe somewhere right around here. And then for point C, let's go ahead and move 5 units to the right, and then let's go ahead and move 4 units down, so something like this. Now it looks like A and C are going to create the base for this triangle because they have the same y-coordinate of -4, and then B is going to be the highest point of this triangle, so that'll help us out with the height. Now we're dealing with a triangle here, so try to remember that for triangles we have the formula area equals half base times height. So let's go ahead and make sure we use that formula, okay? Now for the base we have AC here, so let's find the distance between point A and point C. Okay, so notice they have matching y values of -4. So to find the distance between their x values, we have to add their absolute values since they're in different quadrants. Okay, so for segment AC, we're going to go ahead and say let's add the absolute value of -7 plus the absolute value of 5. And the absolute value of -7 is 7. Absolute value of 5 is 5. 7 plus 5, that's going to be 12. So that's going to be 12 units. Let's go ahead and write that here. That's the base. Let's go ahead and label that as B. Okay, now we need to find the height for this shape here, and so to do that what we can do is let's just take the highest point of where B is, and then let's just draw a vertical line. I'm just going to draw a dotted line so you can see this would be the height of the triangle. So just like earlier, the height isn't as easy to see, but the height must be the distance between the highest point and the lowest point here, right? So B has a highest point of 6, that's its y value, since y measures how high or low something is. And then for A and C, notice that they have the same y value of -4. So we're going to find the distance between 6 and -4, and that'll tell you how far this distance is over here. All right, let's go ahead and add their absolute values. Okay, I'm going to call this point D maybe at the bottom, just making that up. So this is going to be segment BD, right? So that would be this new point just to kind of show where that distance is. And if we add the absolute values, that's going to be the absolute value of 6. That's where B is all the way to the top, plus the absolute value of -4, which is the lowest point of the triangle. And so the absolute value of 6 is 6. The absolute value of -4 is 4. 6 plus 4, that's going to equal 10. So that's 10 units. Okay, so if we go ahead and just draw an arrow, it's kind of getting messy in there. That's 10 units, and we'll call this the height for this triangle. Okay, so substituting into the formula, we have 1/2 times base. The base is 12 units, and the height is 10 units. Multiplying 12 times 10, that's going to equal 120, and then units times units is units squared. So that's 120 square units, and then half of that is going to be 60 square units. Okay, that would be the area for this triangle. All right, for number 7, looks like we have 3 points here, so let's go ahead and create 3 dots. I'm going to call each of these, we'll have D, and then we'll have E, and then F. All right, plotting this on a coordinate plane, we have D, which is going to be 5 to the right and then 8 units up. Maybe an estimate would be there. And then for E, that means we're going to move 9 units to the right and then 8 units up. So that would be maybe somewhere like this. And then for F, we're going 5 units to the right, and then we're moving 7 units down. So that's going to be somewhere in quadrant 4. Okay, so this looks like it's kind of like an upside down triangle. So the base is up here, and then the height, this one actually looks like it's a right triangle, which is kind of nice for us because finding the height's a little bit easier. And then this right here, EF would kind of be the slant here. Okay, so we do have a right angle, which is really nice, and that will help us with the base and the height. Now, I know this triangle is upside down, but the base would be DE in this case, okay? So to find the distance between D and E, notice how they have matching Y values, and if we look at their X values, they're in the same quadrant, so we can subtract their absolute values to find out how far it is from D to E. So let's go ahead and see. For segment DE, that's going to be the absolute value of 9 minus the absolute value of 5. So the one that has a bigger absolute value minus the one that has a smaller one. So this will be 9 minus 5, and that will be 4 units. Okay, so that will be the dimension here. And so this would be the base for this triangle. Okay, now what about the height? Well, the height is going to be this segment DF because they're right on top of each other, above and below. So looking at D and F here, so we have D and F. And notice they have matching X values, which confirms that this is the height. And then we look at their Y values of 8 and -7. Now they're in different quadrants, so make sure we add their absolute values. So let's see here, we have D, F, And so we're going to add their absolute values. For D, looks like we went all the way up to 8, absolute value of 8, and then F goes all the way down to -7. So let's make sure we add the absolute value of that. Now for this, we're going to get 8 plus 7, and that's going to equal 15 units. Okay, so that's going to be how tall this triangle is, and that we can say is going to be the height for this triangle, right? So for triangles, we have the formula area equals 1/2 times base times height, and let's replace and substitute. So the base here we're calling 4 units, and we're calling the height here 15 units, right? Now 4 times 15 is going to be 60, so that's going to be 60 square units, and then half of 60 is going to be 30 square units, so that would be the area for this triangle. Alrighty, one final example here. For example 8 or problem 8 here, we have 4 points E, F, G, and H. Let's just go ahead and label those first. So we have E, F, G, and H. Now plotting these on a coordinate plane, E is going to be 1 to the left and then 6 up, maybe somewhere like here. For F, we're going to go 4 units to the right and then 6 units up, so it's to the right of E. And then for G, let's go 7 units to the right, which is going to be somewhere over here maybe, and then 8 units down, so maybe over here. And then H looks like it's going to be 1 unit to the left and then 8 units down. So it's right next to G to the left of it, but over also underneath E in quadrant 3. Okay, so let's go ahead and connect E and F. They are left and right of each other. Those will be nice. H and G, they're going to be left and right of each other. That's nice. E and H, these ones are also pretty nice because they're right above and below each other as well. And it looks like F and G are diagonal from each other, so that one will be interesting, but we're not going to have to use that hopefully as we're finding the area of this trapezoid. Now to find the area of this trapezoid, I'm going to go about it a specific way, which is called decomposition. I'm going to break this into 2 smaller shapes. So we have EF going across the top here, but I'm also going to go ahead and draw a straight line coming down here so that we've essentially created a rectangle. Okay, so we've just decomposed this into a rectangle over here, and then we can also take a look at this shape that I'm drawing over here to the right, and that's going to be a triangle. So we really have a triangle and a rectangle next to each other. And I'm going to call this point where the triangle meets the rectangle I. Okay, so if we go ahead and find the area of the rectangle, then the area of the triangle, and add them together, we can get the area of the entire shape together. We just add those 2 areas together, right? So let's go ahead and focus on the rectangle first maybe. Okay, so let's find EF. So EF would be here. And so if we take a look for EF, they have matching Y values. And then for X's, they have -1 and 4. Let's go ahead and add their absolute values. So to find out EF, that's going to be the absolute value of -1 plus the absolute value of 4. The absolute value of -1 is 1. The absolute value of 4 is 4. 1 plus 4, that's going to be 5 units. Okay, so that's going to be what this distance is here. And then for EH, that's going to be this length. So let's go ahead and see how far apart they are. Looks like they're in different quadrants, but they have matching X values, right? So we have 6 and -8, so different quadrants. Let's go ahead and add their absolute values. Okay, so for EH, that's going to be the absolute value of 6 plus the absolute value of -8. So that's going to be 6 plus 8, and that's going to be a total of 14 units. Okay, so this right here is going to be the height of the rectangle. So if we want, we can go ahead and call this maybe the length of the rectangle. We can call this the width of the rectangle. So for the rectangle, I'll say area of a rectangle would be length times width. And so the length here would be 14 units, and then the width would be 5 units. So 14 times 5 would be 70. So we have 70 square units. That would just be for the rectangle. So we just figured out the area of this rectangle here to the left. So let's go ahead and see if we can find out the area of this triangle. Now, for this triangle, we really need to have the base and the height. So we know the height of this triangle is going to be 14 units, okay? Now, let's go ahead and see if we can find out the base of this triangle, which is IG. And we really have to talk about this I for a moment. So I is directly below F, but F has an X coordinate of 4. So if I is beneath it, it also has to have an X coordinate of 4. So we're gonna have 4 comma something. Now, what's the Y value for I? Well, I is directly left and right of H and G. So whatever H's Y coordinate is, and G's y-coordinate, it should be the same. So G and H both have a y-coordinate of -8. So if I is at the same level as it, then it should also be at -8. Okay, so how far apart is I and G? Well, we have I here and we have G here, and notice how they have matching -8s. So let's take a look at this 4 and 7. They have the same, they're in the same quadrant, so we can subtract their absolute value. So if we want to find out the length of, I guess, IG, right, then that's going to be the absolute value of 7, take away the absolute value of 4. So the absolute value of 7 is 7, the absolute value of 4 is 4. 7 minus 4, that's going to be 3 units. Okay, so that's going to be this distance right here. It's going to be 3 units, and that's going to be the base for the triangle. Okay, so let's talk about this triangle. The area of the triangle is going to be 1/2 times the base times the height. Now for the triangle, the base we just said was going to be 3 units, so it's going to be 1/2 times 3 units, and we said the height of it was 14 units. Okay, now 3 times 14, that's going to equal 42, so that's going to be 42 square units, and then half of 42 is going to be 21, so we have 21 square units. Okay, now let's go ahead and just take this 70 square units from the rectangle and add that to the 21 square units from the triangle. Now 70 plus 21, that's going to be 91, so we're going to have an area, a total area of 91 square units. All right, so that would be the total area for this trapezoid by decomposition. Now, if you knew the formula for the area of a trapezoid, you could use that too, but this is just another strategy if you don't know that yet. So there you have 8 different practice problems on finding the area of some triangles and quadrilaterals. We had some different types of triangles. We needed the base and the height and then divide by 2. And then for the rectangles, we just needed the base and the height. And for the trapezoid, we broke that up into a rectangle and triangle and found the areas of each of the pieces and then added those together. So I hope you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.